Today we're going to look at rational inequalities. A rational inequality is any inequality that can be put into one of the forms f of x is less than, greater than, less than equal to, or greater than equal to 0, where f is a rational function. There are 5 steps for solving rational inequalities. First, express the inequality so that one side is 0 and the other side is a single quotient. 2. Set the numerator and the denominator of f equal to 0. 3. Locate the boundary points on a number line and separate into intervals. 4. Choose one test value within each interval and evaluate f at that number. And 5. Write the solution set selecting the interval or intervals that satisfy the given inequality. Okay, so I'd like to look at an example where we're solving a rational inequality. And in this case, we have the problem x plus 1 over x plus 3 is greater than equal to 2. So what I've done is I've worked the problem out ahead of time, showing each step. In step 1, you can see where I've taken the problem, set it greater than equal to 0, and then simplified it all the way down till we get negative x minus 5 over x plus 3 is greater than or equal to 0. In step 2, I take the numerator and the denominator, set them equal to 0, and solve each one. This is where I get my boundary points. So in step 3, I place them on the number line. Negative 5 and negative 3 create my intervals. So the first interval that I want to look at in step 4 is from negative infinity to negative 5. The second interval is negative 5 to negative 3. And the third interval, negative 3 to positive infinity. When I do this, I'm taking a test value, meaning any number in that interval, and plugging it into my original rational inequality. So when I do that, if I take negative 6 from the first interval, I plug it in, the answer that I get for this is going to be negative. And that's why I've used my negative sign. A number between negative 5 and negative 3, let's say negative 4, plug it in, I get a positive answer. So that's why I have the plus sign. And of course, in the last interval, from negative 3 to positive infinity, let's say I use 0, my answer that I get out of it is negative infinity. So when I'm looking at this, I want to make sure that the answer I choose satisfies my given inequality statement. So because the interval is greater than or equal to 2, I want to make sure that I'm picking numbers that are also greater than or equal to 2. And in this case, if you look at your test values, you'll notice that the negative 5 to negative 3 interval is the only one that satisfies our given inequality. So in step 5, my answer is negative 5 to negative 3. Now the reason I chose to include negative 5 is because when I plug it in, it works. And when I plug in negative 3 into the denominator, you get an undefined answer, so it doesn't work. So that's why I chose to use the rounded bracket and not the square there. So this is an example of rational inequalities and how to solve them.